We'll start again with number 2, problem decomposition and planning. In this unit, we are going to see what is problem decomposition. In that, we are going to see the goal tree, what are rule-based systems, what are the rule-based expert systems. Then next, we are going to see what is planning. In planning, we are going to see the strips, forward and backward state planning, goal stack planning, and plane space planning, and constraint satisfaction. Okay. Next, what do you mean by goal tree? आवाज नीट ऐकू येतोय का सर्वांना? नीरज
सर बॅकग्राऊंडला काहीतरी आवाज यायचा आता
हा ते साईडला थोडस हे चालू आहे रे, काम चालू आहे, त्यामुळे साईडच्या ह्याच्यात त्यामुळे त्याचा आवाज इकडे येतोय.
त्याचा आवाज आला की मग तुमचा येतच नाही काही.
हा ओके. काय प्रॉब्लेम आला तर मला सांगा, तसं आपण हे करून, कारण साईडला काम चालू आहे त्यामुळे ते स्टॉप तर नाही करू शकत असं आहे.
हो ओके
ओके. नेक्स्ट, what is goal tree? Goal tree is nothing but a tree comprising of node representing the goals. एकच hello. Okay. Goal tree is nothing but a comparison of nodes representing the goals or sub goals. हॅलो, फोनच येत होतं त्यामुळे थोडा हे होतं. गोल ट्री इज नथिंग बट द ट्री कंपॅरिझन ऑफ नोड रिप्रेझेंटिंग द गोल्स ऑफ सब गोल्स. नोड्स कोणत्या कोणत्या असतात गोल ट्री मध्ये? एक तर ते गोल्स असतात किंवा जे गोल अचीव करायला सब गोल्स आपल्याला अचीव करायला लागतात ते असतात. अँड द लिंक्स रिप्रेझेंटिंग द ऍक्शन्स. जे इन बिटवीन तुम्ही इथे लिंक्स पाहू शकता. ह्या ज्या लिंक्स आहेत त्यांना आपण काय म्हणू? दॅट आर द ऍक्शन्स इन ऑर्डर टू अचीव द गोल. And in problem decomposition space, the nodes represent the problems to be solved or goals to be achieved, and the edges represent the decomposition of problems into subproblems. आणखी एकदा सांगतो, nodes काय असतात? These are the, we can call it as a nodes. These we can call it as a nodes. These nodes represents a goal or sub goals. Achieve the final goal. ओके. आता इथे तुम्ही बघू शकता एक सिंपल गोल ट्री आपण एक्झाम्पल म्हणून दाखवलेली आहे. ओके. ह्यामध्ये प्लॅन आउटिंग, जसं आपण एखादी गोष्ट प्लॅन करतो. सपोज आपल्याला दिवसाचा आपला एखादा प्लॅन करायचा. वी आर प्लॅनिंग in the evening we are going to visit the mall, we are going to visit the beach. Again we are planning for the movie. When we are planning for the movie, first we see what are the options available. It can be the matrix, it can be artificial intelligence, it can be a Boolean, or it can be a 7 symbol. Okay. Again when we are going to plan the dinner, in dinner also there can be n number of options, like going to the pizza or going to the on any hotel. Okay, that is a goal trick. Next we are going to see is rule based systems. What do you mean by rule based systems? Rule based systems have been used in general to decompose a problem and address it in parts. So whole problem असेल जे आपण सॉफ्टवेअर इंजिनिअरिंग मध्ये करतो. सॉफ्टवेअर इंजिनिअरिंग मध्ये आपण काय करायचं, वी आर डिकम्पोजिंग द प्रॉब्लेम्स, वी आर फ्रॅगमेंटिंग दॅट इन स्मॉल चंक्स. हिअर in rule based systems we are decomposing an problem and we are addressing that sub problems into the parts. Okay, for that we want the patterns can be actions. Okay, next what is a expert system? Rule based system काय असतात? Next point आहे, what do you mean by the rule based expert systems? Expert system can be explain their reasoning or they can suggest the decisions. Again, expert system can display a intelligent behavior. If a system displays intelligent behavior, it can be the intelligent machine. Expert system can draw the conclusion from the complex reasoning, and expert system can provide a portable knowledge. Okay, these all things can be done by the expert system. Next, what should expert system do? Expert systems share a collection of software packages and tools that are used to develop a expert system. Okay, next point, that what are the limitations कोणते कोणते असतील of the expert systems? Expert systems not widely used or tested. Next limitation, limited to relatively narrow problems. जे खूप छोटे प्रॉब्लेम्स असतात त्यासाठी फक्त आपण एक्सपर्ट सिस्टम यूज करू शकतो. Then there is a possibility of errors in expert systems. Next, we cannot define our own knowledge base. So machine learning मध्ये होतं. What happens in machine learning? Machine learning has its own knowledge base, but in expert system we cannot refine our own knowledge base. There is difficult to maintain the expert systems, and they may have high development cost, and they can rise to the legal and ethical concerns. Okay. Next, what are the capabilities of expert system? We can see the diagram. We can strategic goal setting. Using strategic goal setting, we can set the goal that we have to achieve. After goal setting, we have to plan how to achieve that goal. That is a planning phase. Next, design. In design, we integrate general design principles and manufacturing limitations. Okay. After designing, there is decision making part. In decision making part, we provide advice on the decisions, which link should be followed. Like previously we have seen expert systems, graph tree. In graph tree, which link should we follow? That is a decision making. Next, quality control on monitoring. How the quality should maintain and how to monitor the solutions. Okay. And last is a diagnosis. Look for the causes or any solutions. Next, when to use the expert systems. Okay, we can use the expert system to capture and preserve irreplaceable human expertise. Word irreplaceable human expertise is important. We can capture and preserve the irreplaceable human expertise using the expert system. Then expert system provide expertise needed at a number of locations at the same time or in hostile environment that is dangerous to the human health. Here we can take the example of mining industry. Mining industry मध्ये काय होतं? There is a that environment, work environment of mining industry is dangerous to work for the humans. So using the expert system developed for mining industry, we can work at a number of locations and that is not dangerous to the human health. Okay. Using expert system, we can provide expertise that is expensive or rare. Okay. For developing cost of the expert system is too much rather than hiring the humans. Next, develop a solution faster than the human experts can and provide expertise needed for training and deployment. Next, what are the components of an expert system? The components are knowledge base. What knowledge should that system should have to solve that the problem? It stores all relevant information, data, rules, cases, and relationships used by the expert system. Next, inference engine. What is inference engine? Inference engine has the problem solving module which organizes and controls the steps required to solve the problem. The common example we can take of inference engine involves chaining of if and there rules to form the line of reasoning. Okay, there are again types of solving. There is a forward chaining and backward chaining. We'll see in next slides what do you mean by forward chaining and what do you mean by backward chaining. Next component is a rule. Rule is nothing but conditional statement that links given conditions to the actions or outcomes. Next, fuzzy logic. It is a logic. Then what is backward chaining and what is forward chaining? Backward chaining is nothing but a goal-driven approach, and forward chaining, it is a strategy starts from the set of conditions and moves towards some conclusion. It is also called as a data-driven approach. Forward chaining is data-driven and backward chaining is goal-driven. Okay, you can see the diagram. There is knowledge base. Knowledge base is connected to the knowledge base acquisition facility. This knowledge base acquisition facility is again connected to the inference engine and the experts from the outside. Okay, inference engine is connected to the explanation facility for the backward chaining and forward chaining. Again, this knowledge base acquisition facility is connected to the user interface, and again the user interface is connected to the users. It is a simple diagram of the expert systems. Okay. Then what is explanation facility? Explanation facility is a part of expert systems that allows a user or decision maker to understand how the expert system arrived at certain conclusions or results. Then what is knowledge acquisition facility? Knowledge acquisition facility provides a convenient and efficient means of capturing and storing all components of knowledge base. It is again connected to the expert system. Then expert system development. Expert system development happens in 5 phases. First phase, we are determining the requirements of the expert system. Next, we are identifying the experts to be involved or development. Next, we'll construct the expert system components. Afterwards, we are implementing the results. And last, we are maintaining and reviewing the system. Okay. Then, what are the participants in the expert system development and use? In expert system development, a participant will be the domain expert. Domain expert is nothing but the expert of that system for which that system is going to be developed. Suppose we are developing the expert system for line chaining of an automobile industry. In that case, we require the domain expert from the automobile industry. Then the knowledge user. Knowledge user is the individual or group who uses and benefits from the expert user. Knowledge user is the worker who is going to be use that. An engineer is someone trained or experienced in the design, development and implementation maintenance of the expert system. Okay. We can see the schematic diagram. Expert system can have the domain expert, they can have the knowledge engineer and knowledge user. Okay. Okay. Then what is the evolution of expert system software? Evolution is starting from 1980, where we are going to use the traditional programming languages, first like Perl, then C, CPP. Then in 80s, the special and fourth generation languages we are going to use, like Python. And in 90s, we are going to use the expert system shells. What is mean by expert system shell? It is a collection of software packages and tools to design, develop, implement, and maintain the systems. Advantages of expert system: they are easy to deploy and modify. Expert system uses the heuristics. Heuristic is nothing but exponential, judgmental, and may not be approved or acknowledged publicly. Then development by knowledge engineers and users. To make graphical, we can see the graphical. In that expert system development alternatives, we can use existing package. Again, we can develop from the shell. There is on x-axis, there is time to develop, and on y-axis, there is cost. To use existing package, the cost is low, time is low. To develop a shell, cost is moderate and time is moderate. And to develop from the scratch, to develop from the start, the cost will be high, the time will be high. Applications, we can see the credit granting. You can know the various credit granting applications like Creed, PayPal, etc. Amazon is also providing the credit granting. Purchase now, pay later. Information management and retrieval, AI and expert systems embedded in products. Plant layout, hospital and medical facilities, help desk, employee performance evaluation, loan analysis, etc. can be the applications of the expert systems and artificial intelligence. Okay. Next point, we are going to see what is reasoning. Reasoning, there are two types: backward reasoning and forward reasoning. Backward reasoning is nothing but the if goal is to have a dinner, then it could be achieved by going to one of the two or many restaurants. This form of reasoning is called as a backward reasoning because reasoning is done backward from the code. What happens? Suppose you want to go to the restaurant to have the dinner. Your end state will be the dinner, and for that, to achieve that goal, you should go backward for selecting the restaurants. That is backward reasoning. And forward reasoning, in these rules are triggered by the patterns in the data. Suppose the example, you want to go from place A to place B. You directly apply the rule for going. Rule means what is a method of traveling. In this case, you directly apply method of traveling and you just go to the goal state. In this case, there is no backward reasoning. Next point, what do you mean by planning? The goal of action planning is to choose actions and ordering relations among these actions to achieve specified goals. Take example of driver who has to pick up and drop people from one place to another. Suppose he has to pick two people from two different places, then he has to follow some sequence because he cannot pick the both passengers at a same time. Okay, there is one more definition of planning which says that planning is an activity where agents has to come up with the sequence of actions to accomplish the target. Okay. Next, we are going to see what is strips. Strips is nothing but the Stanford Research Institute problem solver. It is language. In this, language should be expensive enough to explain a wide variety of problems and restrictive enough to allow efficient algorithms to operate on it. Planning languages are also known as action languages. Then what is planning planner? Planning planner basically, do you know, all of you are knowing the wedding planners. Wedding planners, what they do? They plan accordingly your requirements. Okay. Then what is strips? Richard Pikes and Niels Nielsen developed an automated planner called as a strips. Later on, this name was given to the formal planning language. Strips is foundation for most of the languages in order to express, automate a planning problem instances in current use. Okay. Next, we'll see example of blocks word problem. What happens in blocks word problem? Suppose you can see the diagram. This is our basic, or this is our start state, and we have to achieve the goal state like A, B and C. Okay. Here there are certain things we should know, that is precondition. Precondition is nothing but the assertions needed to be true for the operator to be applicable. At least is the assertions, insertions and movement that become true as consequences of operator being applied, and delete list the assertions that are no longer true as a sequence of operator being applied. Okay. Here there is robotic hand can move blocks on the table. The hand cannot hold more than one block at a time. No two blocks can fit directly on same block, and table is arbitrarily large enough for the movement. Okay, you can see the start set. A, on A there is C and B is side. Here there is block A, block B, block C. A is on table, B is on table, okay, and C is on A. Okay. Next, in next step, we have to move the C on the above of B. Here C on B and A is on the table. Next move, we have to again move C to the empty. Okay. What is the stack? Goal stack. Hand empty. We'll have block X, block Y, clear X, and on XY. D, that is deleted list, hand empty, clear X on XY, and A, that is assertion list, holding and clear. Okay. Here we'll stop our today's lecture. Please give attendance in chat box with your roll number and division.